Now we'll see the valence bond theory, the main assumptions of EBT. We have 10 points. We'll see one by one. The ligand and the metal bond in a coordination complex is covalent in nature. The ligand and the metal bond in a coordination complex is covalent in nature. Okay, what is meant by covalent? Last year we have studied what is ionic bond, covalent bond and coordinate covalent bond. Covalent bond is formed due to the sharing of electrons between the ligand and the metal atom or central metal atom. Okay, this is the first point. And the second point, the ligand should have one filled orbital. Okay, the one we have studied what is orbital last year itself. Okay, we have s orbital, p orbital and d orbital and f orbital. Okay, the ligand should have one filled orbital containing a lone pair of electrons. Okay, this is orbital means the ligand should contain the lone pair of electrons. Okay, in order to accommodate the central metal atom. Okay, then the third one, the central metal atom provides vacant orbitals. Okay, the central metal atom provides vacant orbital. Vacant means empty orbitals. Why means, just you see the example here. This is a coordination compound. Here in this case, cobalt is the central metal atom and ammonia is the ligand. Okay, if I draw the structure for this complex, the structure will be like this. Okay, what they are saying, the first point, the ligand and the metal bond in the coordination complex is covalent in nature. Okay, this is the bond. This bond is said to be covalent bond. Okay, this bond is said to be the covalent bond. The second point, the ligand should have one filled orbital. The ligand should have one filled orbital. Okay, containing the lone pair of electrons. If the ligand containing the lone pair of electrons means, then only it can form a bond between the central metal atom. Do you understand? If this cobalt also must have some lone pairs of electrons, and this ammonia also must have some lone pairs of electrons, then only there will be a formation of bond between the central metal atom and the ligand. For that, the central metal atom provides vacant orbitals. Am I clear to you? Next point is hybridization. Last year we have studied briefly about this hybridization. What is hybridization? Hybridization is the process in which the mixing of atomic orbitals are taking place. Hybridization is a process in which the mixing of atomic orbitals are taking place in order to produce the new equivalent orbitals. In order to produce the new equivalent orbitals. This process is called hybridization, and the newly produced orbitals are called hybridized orbitals, and the newly produced orbitals are called hybridized orbitals. Okay, so this is the fourth point. And the fifth point, hybridized orbitals of central metal atom linearly overlap with the ligands to form the coordinate sigma bonds. You know what is meant by sigma bonds and what is meant by pi bond. Sigma bond in the sense single bond, and the pi bond in the sense double bond. Okay, you know this one clearly. Then the sixth point, the hybridized orbitals are directional. Directional in the sense they are directed towards the fixed position. Fixed position means they will have the geometry. Okay, because the ligands which are directed towards the fixed position. Okay, so here these are all the hybridized orbitals, newly produced orbitals. Okay, if SP means SP hybridization means we will get the linear geometry or the structure, and SP2 means trigonal planar. I have drawn the shape of these linear, trigonal, planar, everything I have drawn in the side. Just refer this one. And SP3 hybridization means we will have the tetrahedral geometry, and DSP2 means square planar geometry, and DSP3 means trigonal bipyramidal, and D2 SP3 as well as SP3 D2 means we will get the octahedral complexes. Okay, and this is the sixth point. And the seventh point, here see here, n-1, d1-10, n is 1-2. This is the general electronic configuration of the transition elements. Okay, in in the octahedral complexes, if n minus 1 d electrons are taking part means, okay, see here n minus 1 d means that is also called inner orbital or low spin complexes or spin paired complexes. Spin paired in the sense the spins are paired, plus half and minus half, both are equal cancel, plus of minus of cancel. So the inner orbital complexes are also called as spin paired complexes. Okay, if in the octahedral complexes nd orbitals are taking place means nd orbitals in the sense that is outer orbitals complexes, or these outer orbitals complexes are also called as spin free complex or high spin complexes. Okay, only one spin will be there. Okay, so you have seen this diagram already in the class. Okay, these are all the shells. Okay, here n, which is nothing but the primary quantum number, KLMN, primary quantum number will be the outer orbital. Okay, now you can understand this point. Okay, complexes containing the central metal atom with unpaired electrons are paramagnetic. The complexes containing the central metal atom with paired electrons are called diamagnetic. Unpaired in the sense this one, paired means the spin will be paired here. Okay, and the ninth one, these are all the ligands, carbonyl and cyanide, ethylene diamine and ammonia. These are all the ligands, are also called as strong ligand. These strong field ligand can pair up the electrons. These strong field ligand can pair up the electrons. Okay, then the 10th point, greater the overlapping and greater will be the bond strength. If the overlap between the ligand and the central metal atom is greater means the bond strength also is greater. Okay, the valence bond theory is over right now.